Hi there, let me show you how to convert meshes in Fluvio. Okay, so I will show you how to convert different meshes. Okay, we're going to work with this normal hexagonal mesh, a triangular mesh. In theory, also we support polyhedra, but now we're working in the format to get it working. But for the moment, these two will work fine. You can have even meshes, and we are going also to use this mesh. Okay, it's a back quality mesh. Okay, but just to show you how to do the conversion, and then also later we're going to run the tutorial. One thing important regarding Fluvio is that for the moment we have a dependency in OpenFont to convert the mesh. Okay, so you will need to have OpenFont. You will need to have a complete full installation. You can download the precompiled binaries. Okay, if you are not developing, if you already have it in your computer, okay, you can have your compilation and everything. But for the moment, you can be happy only having precompiled binaries. We're only going to need the conversion tools and the decomposition tool for parallel. So in the link in the description, you will find a link to download a few cases. Okay, so I will enter here, and here we have 3 different cases that we're going to run later, and here we have the meshes in OpenFont. Okay, so this is the first step, that you need to have the mesh in OpenFont. So let me show you that in my case. I'm going to open here, and I'm going to just convert the meshes. Okay, very important as well. Let me show you about the meshes that we do not support hanging nodes. Okay, and that can be positive and negative. Okay, hanging nodes are these nodes here that you see when you see here the transition. Let me go here and to soon see the transition from large cells to small cells. This is hanging node. We don't support those hanging nodes. You need to have a fully conforming mesh like tetra, poly, things like that. So this means that you cannot use SnappyXmesh to generate the meshes. As you know, you have used SnappyXmesh because SnappyXmesh generate those hanging nodes. So you need to use some other meshing tools. Many of the meshes that we use, we generate using tools like Fluid Mesh, Ansys Mesh, and Pointwise. We also use GNSS. So there are many tools to generate meshes that doesn't have those hanging nodes. So just to show you, you go here in Excel, you have one mesh. Okay, and first you need to generate the mesh. Here you already have, remember, you have OpenFont. You need to load the environment variables of OpenFont, and then you run and convert the meshes. Okay, something important that we're going to run in serial, but even if we run in serial, you need to decompose the case with one processor. Okay, and if you're going to use more than one processor, put just 1, 2, 3, put your decomposition. Okay, so here we have everything processor, and here you have decompose, and you choose the number of processors. Okay, in our case, we want just to have one processor. Okay, or as many processors as you like. So that's all. You need to convert the meshes. So usually we convert, if OpenFont comes with tools like Fluent to OpenFont, whatever. So you do your conversion. So let's convert all the meshes. Okay, so we have it there. Also important, the mesh or the data needs to be in ASCII format. Okay, so be careful when you create in the system control dictionary. Be careful to have everything here in ASCII. Okay, so those are the requirements. Okay, so we hope that soon we're going just to we're going to get our own format, just to avoid these requirements or this strong dependency in OpenFont. So now that you have the 3 meshes or all the meshes you want, okay, you put it whatever you want. Okay, something important, you can put your cases anywhere in your installation. So let's work, and let me show you how to convert a mesh here, a simple mesh. Okay, so this tutorial is just simple meshes, and we're going to put some other tutorials, more complex things are in parallel. So as you go in your case, you will find here that we have some files now just to clean the case, clean the grid. Then here you have the readme first. Okay, so I invite you just to open this one. As you see that file open, and you will have the the description of the step to follow. Okay, so as you go there, see the Fluvio, and we'll go to the first one. Something important that we know all the data structure already of the case. We know that here you have boundary conditions, physical properties, post-processing, all the output you have here, and here you have the numerics. Okay, so you see that you have your dictionaries there, your input files. So as you go to grid, you have this is empty. Okay, and when we convert the mesh, everything will be populated. So to convert the mesh, you need to run a command. You go into grid, okay, that folder, and here you have this command, gridgen, that will convert a serial mesh into OpenFOAM format. So it's gridgen -d, and then you give the pass here. So this is relative pass. You can give it absolute, it's up to you. So I will copy and paste here. And okay, so also remember that you need to load OpenFOAM environment variables. Okay, so okay, let me go. Okay, so I have Fluvio master here, source. Let me source the environment variables. Now we have everything. Okay, and we can go back. Validation cases, Laplace, and exit. So you see that to convert the meshes in OpenFOAM or to create, we didn't need Fluvio environment variables. Now to run Fluvio, we need those environment variables. Okay, now that you have it, you go into grid and basically copy here, and this will run the conversion. So it will go look in the mesh that you have in ASCII format, remember, and it will convert it into Fluvio format. So as you go here, see that you have the data structure for Fluvio, the files with Fluvio preposition here, okay, and that's all. Okay, so since that here also when you convert, it will create all this file, but you have all the connectivity, but also you have this file here where you have the name of the boundary patches. So the surface boundaries, you have exactly the same names that you have in OpenFOAM. Okay, so you need to change anything. So how you take everything in OpenFOAM, it is the names that then you need to put here in boundary conditions. If you open this file, the Poisson solver, the file, the variable that solves, it's called T, and you have the name of each boundary surface. Okay, so left, right, top, bottom, and you assign your boundary conditions here. So later when we run the tutorial, we're going to see that. So at this point, we have the mesh, and if you want to visualize the mesh, you go here back. You have the option, you can run the simulation and then convert the solution. You have access to that. But if you don't want to run the simulation, you want to verify everything before running, here we put the command. So you have this command here just to do the conversion in serial. Okay, so you type, okay, now that you do the conversion, you need to go back to your main case, put that one, and it will convert the mesh. So all the fields information, everything is saved here in postprod. So as you go here, BTK fields, see that now you have the mesh data. So if you run the simulation, then you are going to have fields, stuff like that. So this is BTK to open with PowerView, and here you have, okay, we don't have here, when you run here, you have the binary of Fluvio. So that's all, okay? So if you want to visualize your mesh, go like this. Open, you go to postprod, BTK fields, open, and there you have your mesh. And then, well, you need to play a little bit, so you know how to use PowerView, use the options. Otherwise, we're going to put another video also to show you the post-processing. So these are the steps to create a mesh, okay? So these are simple meshes, small meshes, okay, in serial. Later, we're going to put larger meshes in parallel. Something that a large mesh is a little bit time-consuming. Also, we're trying to improve that. But you can convert everything that comes with from OpenFOAM or Fluent, whatever, through OpenFOAM interface, and then you put it in Fluvio format. So let's do the conversion of all the three cases that we have here that later we're going to run. So as you go to the other one, Laplace Kershaw, okay, you go here and again do the same. You go into grid, and then remember that here in the readme you have the instructions, and you can copy and paste this line. So remember gridgen -d and the relative path. and it's doing the conversion. Okay, so this is optional to see the mesh. In this case, I don't want to see the mesh. And now we go to the tetra. Okay, so we have the 3 meshes. Okay, so we can do the conversions, the tetra. You have here, then you go grid, put it there, and you have it. So see here, it's just looking at the directories, running some applications, and converting everything. So see that it's a little bit slow, okay? It's reading in ASCII format and converting in our ASCII in the input format for FLUBIO. So that's all you need to do to convert meshes, okay? Even larger meshes, you can do exactly the same, but we're going to show you some tricks to do it in parallel. In serial, it's exactly the same. Finally, just to end this video, I would like to point out that the script region, okay, which here you have grid region, you have it located there. So let's open because this is script file that is calling some applications, and I would like to point out something that here, okay, you will see this step what it's doing, okay, the programs that it's calling, okay. So it's using this program from FLUBIO, but then reading the meshes in OpenFOAM format. But something important that here you need to point out to the location of your OpenFOAM installation. Okay, so in this case, it's located here. Okay, so if you're using OpenFOAM 8 or whatever you put there, but it's important to give the right location because it will look for those utilities. Okay, to do the composition and everything. So that's all. Okay, so in the description, you will have the link to download these cases. And in the next video, we're going to run exactly these 3 cases. So we're going to run our first tutorial. Okay, thank you for your attention. See you next time. Bye.